Good morning. Today we are going to start with another concept called as logarithmic differentiation. Now, as you would have seen in the previous video, we discussed derivative of logarithmic function. Now, these two are entirely two different things. Now, over there what we did was the derivative of log function, which was 1 upon x, whereas logarithmic differentiation is a procedure. This is a procedure which helps us to find the derivative of composite functions with ease. Okay, so what we do is we'll be using, so whenever we get complicated or complex functions to be differentiated, we make use of logarithmic differentiation, or we make use of the logarithmic procedure to simplify the calculations. So, suppose we are given the function y equal to fx equal to ux raised to the power of vx. That is, suppose a function is given in this form, where this is a function of x raised to the power another function of x. So, there are two functions given in exponent form. Okay, so and here the exponent itself is also a function of x. So directly applying chain rule doesn't help, but we know that using the laws of logarithms, we can convert this from exponent form to product form. So what we take is taking log of both sides. What we get is log of y is equal to log of ux whole raised to the power of vx, but log converts the exponent into product. So this becomes vx log of ux. Now we are able to apply the chain rule. So differentiating with respect to x and applying chain rule. So what do we get? Derivative of log y is 1 over y into derivative of y is dy by dx is equal to, now these are product of two terms. So first of all, derivative of the first function is v dash x into log ux, it gets carried down as it is, plus vx is as it is. Now derivative of this function is 1 upon ux into derivative of ux is u dash x. Now this y goes to the other side, and so we get dy by dx is equal to y times v dash x log of ux plus vx over ux into u dash x. This is the answer. So using this procedure, we'll see that we can do even complex functions in we can differentiate with great ease. So let's start with the exercise 5.5. Now the first question says, let's say call it y is equal to cos x into cos of 2x into cos of 3x. Now if you directly multiply it, you will have to apply product rule. Then again, product rule is applicable only on two functions, so it becomes a very lengthy procedure that you first put two terms together as one, and then and the third one separately, and then apply product rule, then again go on, and it's a long procedure. Whereas if you apply the logarithmic differentiation, this can be done very easily. Let's see how. So taking log of both sides, so what do we get? Log y is equal to log of cos x into cos 2x into cos 3x. Now we know that the product gets converted to sum, and so we get, now here you have to note that we are not writing the base anywhere. So whenever the base is missing, it has to be taken that the base is e, okay, unless and until specified. Okay, so this becomes log of cos x plus log of cos 2x plus log of cos 3x. Now differentiate it and apply chain rule. So now differentiate with respect to x and applying chain rule, we get 1 upon y dy by dx is equal to 1 over cos x. Now derivative of cos x is minus sin x plus 1 over cos 2x into derivative is minus sin 2x, derivative of 2x is 2, plus 1 over cos 3x into derivative of cos 3x is minus sin 3x, derivative of 3x is 3, and so you get the result as dy by dx is equal to y times minus sin x over cos x minus 2 sin 2x over cos 2x minus 3 sin 3x over cos 3x. You want, you leave it like this. You want, you can write tan x in this in place of this, tan 2x here and tan 3x. So now we have seen that with great ease we could solve this question, which otherwise would have been a lengthy procedure. Now let's take another one, which is question number 2. As you can see, the question looks quite complicated because it is square root of, then within the function, within the square root you have x minus 1 into x minus 2 whole upon x minus 3 into x minus 4 into x minus 5. If you deal with it directly using chain rule and quotient rule and product rule, it will be a very lengthy procedure. However, using logarithmic differentiation, it can be done very easily. So let's write it as x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, and in place of square root we are writing whole raised to the power of half. Now taking log of both sides, what do we get? Log y is equal to log of x minus 1, x minus 2 whole upon x minus 3, x minus 4, x minus 5 whole raised power of half. Now we'll use exponent rule, then product rule and quotient rule of logarithms. So what do we get? This gives us log of y is equal to, because of exponential law, this goes into product, so half of log of. Now these are, they get converted to sum and these get converted to difference. So let's quickly write it. This becomes log y is equal to half of. Now what do we get? Log of x minus 1 plus log of x minus 2 minus log of x minus 3 plus log of x minus 4 plus log of x minus 5. Now we differentiate. Now you can open it, all these become negative. So now differentiate with respect to x and apply chain rule. rule, we get 1 upon y dy by dx is equal to half. Derivative of this is 1 upon x minus 1 and derivative of this is 1. So, it remains as it is, plus x minus 2, derivative of x minus 2 is again 1, minus 1 over x minus 3, derivative is again 1, minus 1 upon x minus 4, derivative of x minus 4 is also 1, minus 1 over x minus 5, derivative of x minus 5 is also 1, and so dy by dx is equal to y over 2, 1 over x minus 1, 1 over x minus 2, minus 1 over x minus 3, x minus 4, x minus 5, and that's it. Same way you can try out question number 3, question number 5, question number 3 and 5. So, let's quickly do question number 3. Question number 3 says y is equal to log x whole raised to the power of cos x. So, again applying log to both sides, we get log y is equal to log of log x raised power of log x, and this gives us log y is equal to, this cos x comes here, log of log x. Now differentiate with respect to x, and obviously we will be applying chain rule. We get 1 over y dy by dx is equal to, now this is product of two functions, one is cos x and one is log of log x. So, we get minus sin x into log of log x plus cos x into, now derivative of this is 1 over log x into 1 over x, and so we get dy by dx is equal to y times, this goes minus sin x log of log x, and this becomes plus cos x over x log x, and that's the answer. Now, same way you can try question number 5 also. Thank you.